Jai Hind everyone, myself Sandeep Yadav, Assistant Professor Computer Science Department. Today I am going to deliver a lecture on SDLC model in subject software engineering being taught in 6th semester. So my topic is SDLC, SDLC models. Now outline of the proposed lecture is introduction to SDLC model, waterfall model, prototyping model, incremental model and RAD model. First of all, we will be discussing about what SDLC is all about. SDLC stand for Software Development Life Cycle. Software, the term software itself means it is a set of programs which are collected together to perform a task. Beside this, it also constrains documentation and user manual. Now, coming back to SDLC, SDLC is a process that is used by IT companies to develop, design and test high quality software. These SDLC must meet the requirement of the users, which must reach the completion within times and cost estimation. Now, SDLC has several steps. First, we have to see whether the product that we want to develop is feasible or not. That is, we have to conduct requirement analysis and we have also to conduct feasibility study. In requirement analysis, we will interact with the client to know his requirement. Thereafter, the requirement analysis, we have to design the product. That is, it will cover how part of the software, whereas the previous phase, that is requirement analysis, consists of what part of the system, that is what functionalities are desired in the system. Thereafter comes the implementation part or the coding part, which comes after the designing part. After design is ready, then we will be developing the code or we will be doing the implementation in coding phase. Thereafter will come the testing phase, whereby the ready product is being tested to check whether it performs according to the specifications or not, whether there are some errors or bugs in the software or not. We will be testing with good data as well as the bad data to test the error handling capability of the software, and we will deploy the product after the testing. Now, last phase in this SDLC model is maintenance, which is required for day-to-day activities to make any corrections that has been there due to certain problems in the product, or we want to add certain new features to the product. Now, we will be discussing SDLC models. Various models have been proposed. The first model that has been proposed is waterfall model. So, the waterfall model has the following stages. First stage is feasibility study. First phase is feasibility study. This phase, feasibility study, basically deals whether the product that we want to develop is technically feasible or economically feasible, whether it is possibly that we can develop the product or not. Thereafter comes the requirement analysis and specification. Requirement analysis basically produce a document that is known as SRS. That is, here we will be gathering the requirement from the customer. We will be gathering the requirement from the customer side as well as the developer side will sit together to understand the logics of the proposed software, the expectation of the customer. Those expectations are written in the form of document that is known as SRS, software requirement specifications. Now, this SRS serves as a template or as a contract between the customer and the developer side. Thereafter, we will start with design phase. In design phase, we will be implementing what part of the, we will not be implementing what part, but how the product is to be developed, how, and this part deals with what, how of the system. We will be using a lot of designing techniques, top down designing, bottom up approach, or function oriented design, or hybrid design, or object oriented design. Basically, design phase will give a blueprint that can be used by the next, that is coding team. Now this model itself resembles like a waterfall, that is why it is known as waterfall. One phase will complete, after the completion of one phase, next phase will start. As we are seeing, first this phase is complete, then this will start. After the completion of this, design phase will start. After the completion of this, next phase will start, and so on. Next phase is the coding and the testing phase. Now coding and testing phase, here you will be doing the coding and doing the unit testing. Unit testing means you have to test a individual module. Thereafter will come the integration and the system testing. In integration testing, we will be integrating the modules. We will integrate the module and see after integration the module are working properly or not. That is a very important thing. And last is the system testing, that is after all the modules are being collected together, the system is as a whole is tested to see whether it works fine or not. Various type of testing can be used, extra testing can be used, alpha testing can be used, and beta testing can be used. Now the last phase is the maintenance phase, that is roughly covers the 60% of the portion. Now we will be dealing with each phase one by one. First phase is the feasibility study, which will be determining whether it will be financially and technically feasible to develop the software. Next is requirement analysis and specification, whereby we will decide what is the problem that need to be solved, that is what is the problem of the customer side, which want the product to be developer, what our customer wants. There will be interaction between the software engineer, the developer, and the customer side. We will be identifying the main functionality of the proposed system. These must be documented in the document specification requirement document, that is known as SRS. Now next part is the design part. As we have discussed previously, design part is a how part, that is how the problem is to be solved, that is it is how the problem has to be tackled, that it will consist of two parts, high level design and the conceptual or the detailed design. High level design basically is proposed by the customer side, whereas the detailed design is done by the developer side. We can use various types of techniques for that. Now here the entire module has been, here there are different module, and we will be discussing the detailed functionality of each module. The modules, different system will be divided into different modules, and those modules are clubbed together after completion. Now hey, one thing is very important, that each phase in SDLC has clearly defined entry and exit criteria. Now next is the coding and the testing. Here we will write the code to meet the component and the module design specification. Individual test modules can be written in isolation to test individual module. Then we will be integrating the modules into the subsystems and subsystems into the final system. Next is the integration testing and the system testing. As discussed, various modules are integrated so that they can be tested. Now after the testing is successful, integration testing is successful, we will be carrying out the system testing. Now the last phase and the most important phase is maintenance. This devote nearly 60% of time. Now why maintenance is required? Maintenance is required to meet day-to-day activity. If there is certain error, if there is some error, then that error can be corrected, or we want to add new feature. We want to add new feature to our product, that can also be there, or we want to port our software to new environment. New environment. Now, this activity maintenance is the most time consuming activity that is taking in software development. Roughly this consists 3 to 5 years lifetime on an average case. Now, what are the various shortfall of this model? As already studied that this project, this is model, waterfall model is a linear model. So, all the project cannot follow the linear process. Second, there are no feedback path, as we have seen in the waterfall diagram. There are no feedback path, that is you cannot provide feedback to the previous stages, so that a sort of refinement can be done. Next is, it is very difficult to accommodate change, that is requirements are clearly frozen at the starting. So, it will not be possible to us to accommodate the change at the last. Next, there is no overlapping of phases. After one phase complete, then second phase start. After the completion of second, third phase start. That is, it proceed in linear order. Our model is working in linear model. Then this technique is not suitable for complex projects, whereby we need feedback mechanism, whereby we need to simultaneously execute various phases at same moment of time. So, it will not be possible for us to complete all these at same moment of time using waterfall model. So, when we can use waterfall model? Clearly, we cannot use it every time. It can be used only whenever the requirements are clearly, precisely known in advance. Second, the product definition is stable, that is, it does not go any changes, and the technology is well understood and is not being upgraded. Next, it can be used for a new version of a existing product, or it can be used for porting an existing product to the new platform. Only then we can use the waterfall model. Well, the advantage of waterfall model is that it is a simple model that can be very easily understood by all. It proceeds in a sequential manner which can be easily understood by the customer sides also. Next model that we have to cover is prototype model. Prototype model actually is used when the requirements are not clearly known in advance. So, what we do is, we developed a toy version of the actual product that we have to develop for the customer. So, what we do is we develop the toy version, that is a dummy model. So, first we will see what is a prototype and how to proceed. So, a prototype, as we know, is a partially developed product that enable customer and developers to examine some aspects of the proposed system and design and decide whether that is feasible or suitable or appropriate for the desired or the finished product. So, what we do is, we start with what is known about the requirement. Clearly, some of the requirements are known. So, we will be starting with those requirements. See, in many projects we don't know all the requirement at the beginning. So, whatever requirement is known, we will be doing a quick design using those requirements. So, requirements are not clearly known. Not clearly known. So, in order to understand better, we have to develop the prototype, since the requirements are not clearly known. So, we will be building the prototype by focusing on what will be seen by the user. Now, after developing the prototype, we can use the prototype to show to the user and help in refining the requirement. Now, this is how a prototype model is there. First, we will be developing or refining a prototype. Now this we will be testing the prototype. The prototype after being developed is sent to the customer so that customer checks whether it is clearly gathering his requirements or no. See, developed prototype must give a brief idea or rough idea regarding the requirements. So it will give a brief, it will give an estimate of the requirements. Now if the estimate is proper, then the customer will be using it, and if it is not proper, then customer can discard it. Now what are the drawbacks of this model? See, the customer sees what appears to be a working version of the software and presume it is the final thing. Well, that is not the final. It is only just a limited functionality. A prototype just show the limited functionality. Second thing, the developer often makes an implementation compromises in order to get a prototype working easily. So the performance is not satisfactory. The performance is not satisfactory. Performance is not satisfactory. Only thing is that, only one advantage is that the actual software is being engineered towards quality eye. Now this prototype that we have developed can be used in two ways. Either it can be throwaway prototype, or it can be used as evolutionary prototype. Now in throwaway prototype, after getting the prototype, after it meets the requirement of the customer, then that prototype is thrown away. It clearly has met the conditions. Then that is known as throwaway prototype. That is, it can either end as a throwaway prototype or it can be used as evolutionary prototype. In evolutionary prototype, the prototype that we have developed can be used further to refine it to get the usable product. So the prototype that we have developed will be entering into multiple iterations so that it can be evolved over a duration of time into a finished product. That product can be used, that is used in evolutionary model. Now next model that we have to study is incremental SDLC model. Well, this combines the element of waterfall model in an iterative fashion. Why it is incremental? Because it is going to add the functionality in the system in a number of increments. That is, after completion of one cycle, you will get some product. After completion of next iteration, you will be getting some product, and after completion of next iteration, you will get more functionality. So functionalities are being added sequentially after each cycle, completion of each cycle. So we will be constructing a partial implementation of the system. So we have to decide which requirement is to be developed in first iteration or which requirement is to be developed in second iteration, which requirement will be used in third iteration. So clearly the user requirements are prioritized and the highest priority requirement are included in early increment. Why we are clubbing the highest priority requirement in the early increment? So that we can develop the core functionality first. See, our purpose is to develop core functionality first, so that we will be having some crude form of the software which is a sort of usable product which can be used by the, which can be easily used by the developer, so that we can add the increments in next fashions. So each subsequent release of the system add functions to the previous release until all the functionality has been designed. So this is a diagram showing the incremental model. Clearly we will be having the first increment, Now after the delivery of the first increment, we will go for the next iteration where we will be having the second increment. Now various boxes are being shown here. These boxes clearly demonstrate various phases of SDLC models, that is requirement analysis, designing, coding, testing, implementation, and finally the maintenance. So this increment is and so on till the last increment. So how many number of iterations should be there in our project? Well, it will depend on the product as to how many functionalities should be there, how many steps should be there. We have to see the product, how many functionalities are to be added. If the project is complex, then it will have more number of increments, and if the product is not complex, then it will have less number of increments. So number of increment has to be decided based on the number of the functionalities to be implemented to get the desired software. Now this model has certain drawbacks, that is weaknesses. It requires good planning and design. Second, all the requirements are upfront, that is we should have the early definition of complete and full functional system to allow for the definitions of the requirements. So clearly all the requirement must be upfront. That is a great difficulty because the requirements keep on changing. So it is not possible that all the requirements are upfront. So we should have so to interact with modules, we should have well defined interfaces. Next, total cost of the complete system is not it is not lower, since it will be taking a lot of time. But so why we are using incremental model? Clearly, when we have the staffing problem, we have not the sufficient number of steps, then we can develop it in number of iterations. See, the persons are limited, so we can develop the product in a number of iterations. So those persons who are working in first iteration, they will be working in second iteration also, and they will be working in third iteration also. So we have not to deploy a number of persons. We can work with less number of people, but the total time taken in this model will be more. It will be approximately 1 to 2 years to complete the project. So time is also very essential. Next is when we can use this model is when most of the requirements are known upfront, but some are expected to evolve over duration of time. It is not possible to know all the requirement in the beginning in any project. So requirements keeps on evolving over duration of time. So some of the requirement clearly will evolve over a duration of time, then they can be added in later on stages, when the software can be broken into increment and each increment represent a solution. That is, after each increment we are getting a usable product. So clearly in incremental model, we will be after completion of each iteration, we are going to get some usable product that can be used by the customer. Then a need to get the basic functionality to the market early by developing increments. So first increment itself will have the core functionality. So the product will be easily available in the market at the earliest, when on the project on which we have lengthy development schedule. So clearly this can be used when we are not in hurry to get the product. Suppose someone says that we want the product within 3 months. So it is not possible to develop product using incremental model. It will take time, since we have staffing problem and we are proceeding in increment. So every increment will take at least 2 to 3 months. So depending on that number of increment, it will take more time. So on the project which have lengthy time schedule, we can use this model, and it can also be used on the project with new technologies. Some of the projects which require new technologies can be used this one. Why? Because it is easy to work with this model on new technology, since we are proceeding in step by step. So, we can easily learn the new technology in the meanwhile in the given duration of time. Next model that we have to study is RAD, that is Rapid Application Development Model. As the name indicate, why the name rapid is being used? The name rapid means we have to develop the product at the earliest. That is, the product is to be developed at the earliest. So, that model has to be used. Now, it is an incremental process model that emphasizes the short development of time. It uses a lot of development tools and techniques. It use a lot of development tool like case tools are already available, testing tools are already available. So, using tools we can speed up our development process. It is a high speed adaptation of the classical waterfall model. That is, all the phases that we use in waterfall model are being used here, but we have to proceed fastly. That is, we have to complete it in a shorter duration of time. That is, next itself short span of time. See the time box for this model is 60 to 90 days. That is, RAD model will take 60 to 90 days to develop. This clearly means it has a short time stamp. That is, product will be available after 2 to 3 months. Now, this approach also maps into generic framework activities, that is planning, requirement, deployment, all those generic framework activities. Now, this is a diagram which shows the rapid application development. See, there is communication between the user side, that is the developer, and the customer side. Now, after the proper communication, the communication must be proper. There must be, since the product is to be developed at the earliest, so there must be heavy or high user slash customer interaction. With the developer side. Since the product has to be developed at the earliest, so they must be interacting daily. Now, then we will be starting with after communication, the planning will be there, the analysis part will be over. Now, there are different. Now, this model is used when it is possible to split your system to a number of modules. Now, each of the modules will be worked by a different team. We have split our system into a number of modules. System is being split into a number of modules, and each modules are worked by separate. Each module will be worked by a separate team. Now, the model itself may be business, it related to data or process. Now, within the construction we are seeing the component reuse, that is, the reusability is there, then automatic code generation is there, then testing is there. Clearly, there are a number of teams. So, the staffing problem is not there. We should have enough manpower. If we want to use this, if this model is to be used, we must have enough manpower. Otherwise, it will not be possible to use this model, because various teams are working together simultaneously. So, here the number of people used are large as compared to the incremental model, since we have to develop the product in a single go. So, different modules are being developed together. These modules will be integrated together to get the system ready. We will be doing the testing also, we will be doing the unit testing also. Each of the module that is being developed will undergo unit testing, that is, as in unit testing each module is being tested separately to check whether it has some error or not, whether it is performing the functionality or not. Thereafter the integration testing is being done. When separate modules are clubbed together, we have to see whether these modules after clubbing together these modules are working properly or not. Then for that we need integration testing. Finally, after whole of the system has been integrated, we have the system as a whole. Now the system as a whole has to be checked. For that we will be carrying out the system testing. Now various type of system testing is available. Acceptance testing is there, alpha testing is there, beta testing is there. So those testing can be used to get the final testing done. Now what are the drawbacks of this model? For large product, RAD requires sufficient human resources to create the right number of RAD teams. If the developer and the customers are not committed to rapid fire activities, RAD product will fail. RAD activities will fail, that is, we have to have the sufficient manpower, otherwise it will not be feasible. Second, there must be heavy interaction. If the two sides are having the rapid interaction, then this model will fail. If the system cannot be modularized, building the component will be problematic. Second, next, that is, if high performance is an issue, it will not work. If the model will not give very high performances, it is developed very quickly, so that will not be possible, and it may be inappropriate where technical risks are high. So when to use this model? When we have reasonably well known requirements, users are involved throughout the life cycle, project can be time boxed, functionality delivers in increment, high performance is not an issue, there are low technical risks, and system can be modularized. Thank you.